It came out of nowhere, a bright speck in the sky, soon streaking across the horizon, followed by an almost apocalyptic scene, a blinding flash of light, and then all hell broke loose.
In case there was an asteroid coming towards Earth and you're there, you can actually stop it. I mean, that's kind of fantastic.
NASA is crashing a spacecraft into an asteroid.
What? You think science fiction, but this is real. Never in my life would I have thought I would take a couple $100 million spacecraft and crash it into an asteroid.
A spacecraft named DART will zero in on the asteroid intent on slamming it head-on at 14,000 miles per hour. The impact should be just enough to nudge the asteroid into a slightly tighter orbit around its companion space rock, demonstrating that if a killer asteroid ever heads our way, we'd stand a fighting chance of diverting it.
Only be changing the period of the orbit of Dimorphos by a tiny amount.
But in space, just a little bit is just enough to make an asteroid actually miss us.
In the event that an asteroid is discovered well ahead of time before it might impact Earth.
We've all seen the disaster movies where we see tidal waves and we have material that's ejected into the atmosphere. It could be a worst case scenario, which is why it's really important to test this.
It is important because it can make us disappear like dinosaurs. NASA program scientist Tom Statler said, "This is stuff of science fiction books and really corny episodes of Star Trek from when I was a kid, and now it's real. Cameras and telescopes will watch the crash, but it will take days or even weeks to find out if it actually changed the orbit." The $325 million planetary defense test began with DART's launch. In our known past, we have few encounter with asteroids, and every time it terrify people to hell.
The eyes of the world today stunned by this image. This was debris from a meteor racing toward Earth, streaking across the sky there, crashing into the ground in those woods. And look at some of the other images emerging tonight. The cloudy trail the meteor produced, and on impact, this, carving a little pool into a frozen lake. It's the biggest meteor in more than a century to hit the planet. This one crashed in Russia. 1,000 people were injured from shards of flying glass and debris. Tonight here, we have learned there was no warning.
Impact would have leveled the city, and there's countless other threats out there that could have devastating consequences.
We've seen asteroids come through the atmosphere and kind of explode and cause some damage. And thankfully so far, nothing recent enough that it really has a large impact on our civilization, but it could happen.
That's why NASA isn't waiting for humanity's luck to run out, launching the DART mission aboard SpaceX's Falcon 9 rocket.
Liftoff of the Falcon 9 and DART.
The mission, lifting off last year, has been hurtling towards two asteroids with intertwined orbits, called Didymos and Dimorphos, nearly 7 million miles from Earth.
Dimorphos is orbiting around Didymos, kind of like the moon orbits around the Earth.
Dimorphos may be smaller than Didymos, but it's still big, over 500 feet wide, about the size of a large football stadium.
A rock of that size hitting the Earth would have enormous amount of energy if it hits the Earth. Something like that would level small state, small country.
Yeah, you heard that right. A small country. These two asteroids are not a threat to Earth, but scientists say the pair have perfect conditions for this first-of-its-kind test.
It's really a zero-risk, high-reward test of our ability to defend our planet.
What we're going to do is we're going to run a small spacecraft into the smaller of the two asteroids, and it is going to change its velocity by a small amount. These two asteroids are slowly moving around each other. So that tiny little change in velocity that you make to one asteroid, you can see it almost immediately.
To make the collision happen Monday, a smaller probe will be jettisoned from the larger spacecraft, ramming into the asteroid. NASA will be relying on smart nav technology that includes a sun sensor, star tracker, and rollout solar arrays to keep the spacecraft light, but it comes with a catch.
About 2 minutes out, we have to stop maneuvering, and we're moving at 6 kilometers a second. So if you actually look at that on the map, it's as if we were over the Indy 500 when we stop maneuvering, and then we simply have to coast all the way to Baltimore, and we have to land inside Camden Yards.
It's a remarkable amount of precision for a small nudge that could have giant implications for planetary defense if successful. NASA hopes to measure the altered course of the asteroid caused by the collision.
Within days here, we should know by exactly how much we've been able to change its velocity. And that's the whole point of the mission. Make a tiny change in the velocity, because that's all it takes to protect the Earth in general from most asteroid impacts.
And while a successful mission may ensure humanity's ability to deflect a future threat, it's only half the battle. Tracking asteroids in our solar system is key.
Right now, the vast majority of the asteroids that are large enough to destroy a city are untracked.
A sobering reality that will soon change.
Our ability is just about to take a quantum leap forward, and that's because the world's largest telescope for finding tracking asteroids is just about to have first light next year.
Called the Vera Rubin Observatory, it's a joint venture under construction in Chile that will be a game changer in asteroid detection.
This telescope is going to track asteroids at a rate about 10 times more than all other telescopes combined. So that's really going to help us find a lot more asteroids.
The observatory and missions like DART offering a last line of defense for our planet to help protect the future of humanity on Earth.
While on the ISS, you're struck by the fact that the moon has so many craters there, craters on top of crater, and you go, wait a second, the Earth gets hit more often than the moon. From this point forward, if it happens while we're here, that's not bad luck anymore. That's us not doing our job at protecting this planet. And that's what DART's about.